What's up, sixth graders? This is lesson 9, day 3, and you are going to be subtracting decimals out to the thousandths place. So if you have your math book, make sure it's on page 96, and let's get started. First, we're going to read this problem at the top. It says, Walter wanted to compare the great pitcher, Walter Johnson's earned run average, his ERA, to other great pitchers to find out how much lower it was. A lower ERA is better than a higher ERA. He found these pitchers' lifetime ERA statistics. So Walter Johnson had a 2.167 and Sandy Koufax had a 2.76. How much better was Walter Johnson's ERA than Sandy Koufax's? First off, did you notice the key words? How much better is like how much more? And that always means to subtract. So keep that in mind. Now, we're going to go down and talk about 3 strategies, which are similar to our strategies with addition yesterday that we're going to use to solve these problems. First is the estimating strategy. So it says you can round each decimal fraction up or down and then compare them in your head. For example, 2.167 is close to, that would round to 2.2 because that 6 rounds the 1 up to a 2. And 2.76 is close to 2.8. And that is because the 6 rounds the 7 up to an 8. And then you can compare those in your head. You can compare 2.8 minus 2.2 to come up with an estimate. Now, for the picture it, we're going to use a place value table. So in this one, we would take the number that's bigger and put it on top. So 2.76 would go on top. There's 2 ones, 7 tenths, 6 hundredths. Minus 2.167, 2.167, and always fill in that empty spot with 0. Okay, so we can subtract in a place value table. Last, use the place value table to help us line up our problem. So we could have our problem as 2.760 minus 2.167. So 3 strategies there: estimating, place value table, and getting the problem written down. All right, on the next page, you're going to be working through solving this problem. So here's what we're going to do. First thing I want you to do is you're going to work on 10 through 12, and I do want you to pause the video as you're working on them. And when you're done, restart the video and check your answers. If you are stuck on any of these, you do have permission to play the video and work on the problem with the video. All right, ready? Do these 3 problems, pause the video, restart it when you're done. Go. All right, let's see how you did. So in number 10, it says, look at estimate on the previous page. What is an estimate of the difference? Now remember, on the previous page, our estimate up here was 2.8 minus 2.2. So if you were doing 2.8 minus 2.2, your estimate would be 0.6. Okay, explain your reasoning. Just say, I rounded to the nearest tenth, and subtracted. Okay? Now, you don't have to have those exact words, but I'm just explaining my reasoning for that problem. All right, number 11 says, how is subtracting decimals similar to adding decimals? You can have a lot of different things in here, so you don't need to have exactly what I had. But when I think of how they're similar, I would say one way they are similar is that you must line up your decimal points. Now, there are other ways they are similar, but that, to me, is the big one, how subtracting and adding decimals are similar. All right, and in 12, why is it important to pay attention to the 0 in the subtraction problem? I'm going to show you first, and then I'm going to write my reason. In a subtraction problem, I don't want to give you your answer yet. Do they have you solve it yet? I don't think so. in subtraction, if you have, let's say, 4.1 minus 2.13, if you don't put a 0 here, what ends up happening is a lot of people just bring down the 3 and subtract, which is wrong. Because when I go back, you'll see when you fill in the 0, you can't do 0 minus 3, so you have to actually borrow. And 10 minus 3 is 7, and you'd get 1.97. So you must pay attention to the 0, otherwise you might not regroup. So I'm going to explain that here in my own words. I'm going to say the 0 in subtraction is important because you need to regroup to get the correct answer. Now, correct, let me finish that. Again, you don't need my exact words, but your answer should say something about how the 0 is needed. It should have something to do with regrouping. If your answer doesn't have that, you want to change it in your own words. Okay, remember, you can pause the video if you need to make any corrections. Now, next thing you're going to do is 13 through 16 on your own. Pause the video, do those 4 problems, and restart it when you're done. Go. All right, let's see how you did. So in 13, it says, how much better was Walter Johnson's ERA than Sandy Koufax's? Find the difference and model it on the previous page. Explain how you know that your answer is reasonable. So I'm actually going to go back and solve on the bottom here, and we'll see if you got the same answer. So remember that 0 is important because you can't do 0 minus 7. So I borrow from the 6, make it a 5. 10 minus 7 is 3. Can't do 5 minus 6. Do some more regrouping. 15 minus 6 is 9. 6 minus 1 is 5. Keep your decimals lined up. And 2 minus 2 is 0. So this is my answer, 593 thousandths. So how much better? His ERA was 593 thousandths better. Now, explain how you know your answer is reasonable. Remember up at the top what I estimated? And I estimated to 0.6. Notice 0.593 is really close to 0.6. So, my answer is reasonable. Because it is close to my estimate. And my estimate was 0.6. All right. Now, if you made a mistake, make sure you fix it in your subtraction. Number 14 says, what is a way to check your answer? Now, to check any subtraction answer, you can use addition. So, I'm just going to say that. You can add to check your answer. And I'm actually going to do that. So what I'm going to do is I'm going to take, let me switch to a different color here. How about some green? I'm going to take my answer and add it to the bottom number and see if I get the top number, which was 2.76. So I'm going to do 0.593, add it to 2.167, and I get 10, 16, 7, 2, which is the top number. Okay, so now I'm just going to explain what I just did here. So you can add to check your answer. just add 0.593 plus, I forget the numbers now. I guess I have to look back on the other page. 0.593 plus 2.167 to get 760? Yep. All right. Okay, so if you said something along those same lines, don't change your answer. If you made a mistake, you have time to pause it and fix it. 15 says compare subtracting decimals and subtracting whole numbers. All right, so I'm going to show you first what I would compare. If you are subtracting whole numbers, let's say you're doing 27 minus 6. You always line it up, so the digits are always lined up over to the right side of the problem. They're lined up against that imaginary line, so you can solve. Now, when you're subtracting decimals, let's say 2.7 minus 6, or minus 0.06. You don't do that. You make sure your decimals are lined up. So you would have 2.7 minus 0.06, and you'd have to fill in the zeros to keep everything lined up. So I'm going to erase that, but I'm going to explain that here. Okay, so when I compare them, let me see. Let me start here. I'll start with whole numbers. Okay, so here's what I said about whole numbers. When you subtract whole numbers, you line the numbers up on the right. But now I'm going to compare that to decimals. So I said when you subtract decimals, you need to line up your decimal points. Now you could have said something different, and that's fine. These are just what I compare them. All right, now if you want to take any ideas from mine, feel free to add them to your answer. Last, explain how to subtract decimals to the thousandths. Well, I would say make sure you line up your decimals and fill in empty spaces with zeros. Remember, if you don't fill in empty spaces with zeros, you might mess up the regrouping. All right, so now, remember, you could pause the video and make any corrections you need to. But now we're going to go down and work on two problems here. So it says, use what you just learned to solve these problems. Show your work on another sheet of paper. Okay, so you're going to start and you are going to do just number 17. Do it on another sheet of paper, or if you have room on this page, that's fine. I don't care. Pause the video while you're doing 17. Restart it when you're done. Go. All right, let's see how you did in number 17. It says Sandy Koufax had a 0.655 win-loss percentage. Walter Johnson's was 0.599. How much higher was Koufax's win-loss percentage than Johnson? So, how do you know this is a subtraction problem? Well, it tells you with these words, how much higher. That's just like how much more, how much bigger, how much smaller, always means to subtract. So I'm going to put the higher number on top, which is 0.655, and I'm going to subtract the smaller number, minus 0.599. Now, because they both go out to the thousandths place, I do not need to add any zeros. So let me start. I do need to do some regrouping. 15 minus 9 is 6. Need to do some more regrouping. 14 minus 9 is 5. 5 minus 5 is 0. So the answer to this one was, it was 0.056 higher. Okay. If you had that right, good. If not, don't just change your answer. Make sure you look at the problem and see where you messed up and make your correction then. All right, so now you're going to do number 18 on your own. So do number 18. Again, pause the video while you're doing it. Restart it when you're done. Go. So, in number 18, it says, Tyrone needs to take 4.5 milliliters of cough syrup, but only has 2.745 milliliters. How much more does he need for a full dose? So those words, how much more, again tell you it's a subtraction problem. So to figure out how much more he needs for a full dose, I'm going to subtract. So I'm going to start 4.5 minus 2.745. And I'm going to fill in those empty spaces with zeros. If you don't do that, you're probably going to get it wrong. So now, I can't do 0 minus 5, so let me do some regrouping. That becomes a 4. This 10 becomes a 9. And this 0 becomes a 10. 10 minus 5 is 5. 9 minus 4 is 5. Need to do some more regrouping. 14 minus 7 is 7. Line up your decimals. 3 minus 2 is 1. So how much more does he need for a full dose? He needs 1.755 milliliters more. All right, so if you had that one wrong, make sure you make your corrections. And guess what? You're done. As always, thanks for watching, guys.